Hey everyone, welcome back to Trigonometry. This is going to be lecture 12 of the course. And in this section, we're going to talk about two more groups of trig identities. The product to sum formulas and the sum to product formulas. So let's go ahead and jump into it. And we'll start with the product to sum formulas. Right, we'll start with the product to sum formulas. Now, as the title implies, the value in these formulas is that we can take a product of trigonometric identities, like maybe a sine times a sine or a sine times a cosine, and we can convert it into a sum or difference, as the case may be, right? So let's write them all out first, and then we'll see where they come from. These are easily derived. So the sine of alpha times the sine of beta. So here's your product. That's equal to 1/2 times the cosine of alpha minus beta minus the cosine of alpha plus beta. Right, so as the name indicates, you start with a product, sine times sine, and you end up with an expression that is not a product of trig functions, but instead is a difference, or a sum or difference. Okay. So that's the version for sine times sine. What about cosine times cosine? Well, it's going to have a real similar form. It's cos alpha minus beta, and then it's plus cos alpha plus beta. That's cosine times cosine. What about sine times cosine? What about sine alpha times cosine of beta? Well, it's 1/2, and then it's sine of alpha plus beta plus sine of alpha minus beta. Okay. Now, technically, you could also think of reversing the order here, cos alpha sine beta. I mean, it's a little redundant, but because, I mean, really the order is sine cos, cos sine sine, you could just as well rewrite them. But just in the interest of having everything kind of labeled correctly and keeping straight what's in front and what's behind, you can just think of this as a separate case. But it's going to have a real similar form. It's going to be sine of alpha plus beta and minus sine of alpha minus beta, just like so. Okay, and the derivation of these is going to be very straightforward. So to derive these, we're going to use the sum and difference formulas. Okay, so let's say I'm interested in deriving sine alpha sine beta, this first one. Well, it turns out to get to that one, what I need to use is the cos alpha minus beta. Right, so this was the sum and difference formula from the previous section. So I use the cos alpha minus beta, and then I also use the cos alpha plus beta version. So these two, so I need to write them both out in complete. Right, so I have cos alpha, cos beta, plus sine alpha sine beta. Now remember, I'm just going back to my previous lecture notes and just grabbing these formulas. These are from the previous lecture. Right, and so cos alpha plus beta was cos alpha cos beta minus sine alpha sine beta. All right. Now you can see, if you kind of look at this, that I've, this part here is probably this, and this part here, this cos alpha plus beta, is probably this. And so in the formula up here, I subtract the two. And so that's indeed what we want to do here. We want to subtract one from the other. Right, and so you've got to be a little bit careful when you do this to make sure that you're doing it properly and carrying the negative sign through properly. So you have cos alpha minus beta minus cos alpha plus beta. Right, so that's what you get on this side of the equal sign when you do the subtraction. Now over here, I've got cos alpha cos beta minus cos alpha cos beta. These are the same, and so when I subtract one from the other, they go to 0, right? So this is just 0 when I subtract that. Over here, I've got sine alpha sine beta minus negative sine alpha sine beta. So I'm subtracting a negative, and so that means I'm adding. So this is sine alpha sine beta plus sine alpha sine beta. Sorry, equals sine alpha, and I'll write it all out, sine beta plus sine alpha sine beta, right? So minus a negative gives me the plus. And this is just, these are the same two terms twice, all right, so you can just add them together. So I get cos alpha minus beta minus cos alpha plus beta equals 2 sine alpha sine beta. Now I'm almost done here, right? The sine alpha sine beta is what I'm trying to get this one side into that form, right? And so I just need to divide both sides by 2, right? So I get sine alpha sine beta is equal to 1/2. I'm going to divide this side by 2, right? So 1/2. And then it's cos alpha minus beta minus cos alpha plus beta. There we go. And so that is the simple derivation. You're basically just taking the two sum and difference formulas and subtracting them. And when you do that, you get this guy, this one right here. Right? And so this one here is that one there. Okay? So real simple derivation kind of falls out of just that subtraction. So the other ones work in a similar way. You just have to figure out which ones to subtract to get what you want, right? And that's just as simple as kind of looking at the formulas. Okay, so let's do a quick example here. Now there's lots of places where this is useful, but the main one is, I think, in being able to just reduce a product to a sum, right? Like that comes up at oftentimes in, when you're working with proving trig identities, or when you're trying to evaluate expressions or solve trigonometric equations, as we'll be doing in a little bit. This comes up, right? So let's try to express sine of 8x sine of 3x, right? So I've got this product, sine of 8x times the sine of 3x. Let's try to express this as a sum or difference. Right, this is super easy. We can just say alpha is 8x and beta is 3x and just use the formula, right? So I have sine of alpha, sine of beta, right? Sine of alpha, sine of beta, that's the form. And I know that's equal to 1/2 times cos alpha minus beta minus cos alpha plus beta. Right, I know that's just the formula, right? So I can just plug in my actual angles, 8x and 3x, and I get the answer. So sine of 8x times the sine of 3x is equal to 1/2 times the cosine of 8x minus 3x minus the cosine of 8x plus 3x. And I can add those angles right over here, and so I get the sine of 8x times the sine of 3x, the product that I want to get rid of, can be written as the difference by doing 1/2 cosine of 5x minus cosine of 11x. Okay, and so here would be, that's the goal, is to re-express it without the product. All right, so that's pretty straightforward. Okay, And so there's more examples we could do, but I think that's where we'll stop with that one. Now let's switch to the sum to product formulas. Right, this one has a little bit more involved of a derivation, so I want to make sure to get to this. So these are the sum to product formulas. Right, and so these are just the reverse of what we just talked about. So in the examples we just went through, we had a product of trig functions and we want to convert it into a sum or difference. Here we've got a sum or difference of trig formulas, so like sine plus sine or sine minus sine or cos minus sine or whatever. And I want to convert them to a product. Okay. And so let me write these out here. So sine plus sine, sine minus sine, cos plus cos, cos minus cos. Okay. So here they all are. So if I have sine of alpha plus sine of beta, right? So a sine plus a sine, then that's equal to 2 times the cosine of, now the angle gets a little strange here, it's alpha minus beta over 2 times the sine of alpha plus beta over 2. Okay, so that converts like that. And what if I'm subtracting sine of alpha? What if I'm subtracting sine of beta from sine of alpha? Well, it's real similar. It's 2 times the cosine of alpha plus beta over 2 times the sine of alpha minus beta over 2. Right, you're just kind of flipping these, and so they should be pretty much the same except the arguments. Right? And then for cosine, we have something similar. Cos alpha plus cos beta. Right, that's going to be equal to 2 times the cosine of alpha plus beta over 2 times the cosine of alpha minus beta over 2. So that's the cos plus cos. And now what about cos minus cos? Well, it's actually different. It's negative 2 sine of alpha plus beta over 2 times sine of alpha minus beta over 2. Okay, so these are the sum to product formulas, right? So I've got 2 trig functions that are written as terms. I can re-express them as factors of one another using these formulas. Okay, and so for these we're gonna do a derivation here, and these are just a little more involved, but the derivation is going to start with the product to sum formula, right? So we're going to start with the product to sum formulas that we just looked at. So we begin with a product to sum formula. Okay, and so the one we'll use is sine alpha cos beta. And we know that that's equal to 1/2 times sine of alpha plus beta plus sine of alpha minus beta. Right, so that's the product to sum formula that we just talked about. And first thing we want to do is kind of get rid of the 1/2, so we'll multiply both sides by 2. And so we get 2 sine of alpha cosine of beta equals sine of alpha plus beta plus sine of alpha minus beta. Right, so just kind of got rid of that 1/2 business. Okay, now we're going to re-express alpha and beta. Right, so let's let alpha equal theta plus gamma over 2. Okay, and we'll let beta equal theta minus gamma over 2. Okay, so we're going to re-express these two angles. Okay, And so when we do that, we can plug those values in. We can plug those, this substitution in throughout the expression. Okay, so we can plug that in throughout the expression, and we get 2 times sine of, it was alpha, now it's going to be theta plus gamma over 2. And then cosine of, it was beta, now it's going to be theta minus gamma over 2. And that's going to equal, I'm going to put it on another line here, 2 times so here, so it's going to be equal to 2 times, I'm going to leave the 1/2 in there actually. And so this is going to be sine of theta plus gamma over 2 plus theta minus gamma over 2, right? Because it's alpha plus beta, so alpha plus beta. Okay. And so that's the sine, and then plus the other sign, this guy here. So plus sine of theta plus gamma over 2 minus theta minus gamma over 2. Okay, and that gets us what we need there. Okay, so just be a little bit careful here. It's 2 times 1/2, and we'll sort that out in the end. Just hang with me on that one. Okay. So we need to simplify these arguments, obviously, right? And so this is going to be equal to the 2 and the half will cancel, right? So we could have just done that from the start. But it's going to be equal to sine of theta plus gamma plus theta minus gamma. Okay, and that's all over 2 plus sine of theta plus gamma, and then it's minus theta, and then it's minus gamma, so it's minus theta plus gamma. Right, so it looks like this. All right, and so you can see what's going to end up happening here. You're going to have sine of, it's theta plus theta, and then it's gamma minus gamma. So I basically get 2 times theta over 2 in here, don't I? The gammas go away. And then over here I get sine of theta minus theta, so the thetas drop out, and it's gamma plus gamma over 2. So 2 gamma over 2. And so I can just write this as sine of theta plus sine of gamma. Okay. All right, and so that's the entire expression, right? I start with this, and I derive it, I end up with this. And so that is actually the formula, right? So instead of thetas and gammas, let's plug in alphas and betas now. So sine of alpha plus sine of beta is equal to 2 times the sine of alpha plus beta over 2 cosine of alpha minus beta over 2. Okay, and so that's the derivation we were after, right? This is equivalent to the first sum to product formula. So you sine alpha plus sine beta is equal to this. That's what we just derived. Okay, so perfect. So that's the derivation, and then the others work similarly. Now these can be a little bit more involved, so take your time if you're going to try to derive 1 or 2 more of them, which I encourage you to do. Let's do an example, though. Let's do an example. We'll just kind of do the reverse of the example we did for the product to sum. So let's say we want to express the sine of 9x plus the sine of 5x as a product. Well, again, we'll just let alpha be 9x, beta be 5x. Then we know that sine of alpha plus sine of beta is equal to 2 times the cosine of alpha minus beta over 2 times the sine of alpha plus beta over 2. Right? And so we just plug in those values. So I know that sine of 9x plus sine of 5x is equal to 2 times the cosine of, so it'll be 9 minus 5 times the sine of 9x plus 5x, right? Alpha plus beta. And of course I can simplify this. So it's equal to 2 times the cosine of, now what's 9 minus 5? That's 4. So I have 4x over 2. So this is really just 2x. Right? And then over here I've got 9 plus 5, which is 14. So 14 over 2 is 7. So times the sine of 7x. Okay, and so this expression here is equivalent to the given expression, but it's obviously not. I mean, it's a product, right? So it's not a sum. Okay, very good. Let's do one more example where we use these guys to verify a trig identity. So let's say we want to verify that the cosine of 3x minus the cosine of 5x divided by the sine of 3x plus the sine of 5x, that's all equal to tangent of x. Crazy, but true. Let's see. So we're obviously going to start with the left-hand side. So we'll say the cosine of 3x minus the cosine of 5x divided by the sine of 3x plus the sine of 5x. So what can we do with this? Well, we're going to basically use the sum to product on this. I've got a sum, and I'm going to convert it to a product. Right? And so I'm going to do that on the top and the bottom separately. So the top is cos minus cos, and so just look up that formula, and you'll see that when you look that up, you should get -2, and then it's sine of, and it's alpha plus beta over 2, so that's 3x plus 5x over 2, and then it's times the sine of alpha minus beta, which is 3x minus 5x over 2. So that's the numerator. We could do something similar for the denominator, and we get 2 times the sine of 3x plus 5x over 2 times the cosine of, and then for the cosine it's alpha minus beta, so it'll be 3x minus 5x over 2. All right, so we get that. Let's simplify this whole mess here. So we get -2 times the sine. Now what is this? This would be 8x over 2, so it's just 4x, isn't it? And then here I've got the sine of 3x minus 5x, so that's -2x over 2, so this would be -x. Okay. And then down below I've got 2 times the sine of, again, another 4x. And then this will be the cosine of another -x. Okay, so I end up with this. And so I could simplify this. The 2's cancel, the sine functions cancel, and on top I get negative sine of -x and then below I get cosine of -x. So it simplifies down a lot. I'm getting close to having tangent of x. Sine over cos is tangent, but the arguments are kind of mixed up here, right? So what can we do? Well, we can use even odd functions here. We know that the cosine is an even function. So cosine of -x is just equal to cosine of x because it's an even function. Sine is an odd function, so sine of -x is equal to negative sine of x, like so. Right? And so this is all going to work out perfectly because I've got minus and negative, and so that means I just have sine of x on top, and then on the bottom I just have the cos x, and that's equal to the tangent. Right? So we went from this equals to this. And so that's the verification. So we verified this identity. All right, and so I think we'll end this lecture a little bit shorter than the others, but just because the material is kind of straightforward and the derivations are kind of simple. Next time we'll start talking about what are called trigonometric equations, and so sometimes this can be a little bit tricky. The idea here will be to solve equations that involve trig functions, and so we'll be using a lot of our algebra and obviously a lot of our trig formulas and our various identities that we've been working through. But that'll be next time. That'll be trigonometric equations. So until then, everybody take care, and we'll talk to you later.